Hey guys, me again. In preparation for the upcoming assessment and your final assessment, I wanted to walk you through the process of creating a Plotly project from scratch. In doing so, we'll learn how to explore our data, filtering and adjusting our view of it in order to better understand it and the story that it can tell. In doing so, we'll become better data storytellers because we'll be able to quickly test and then potentially either discard or follow up on our hypotheses as we figure out if they are relevant to our story or not. In doing this, I hope to teach you not only some of the skills that you need to manage more complex visualization projects in Plotly, but also cover some of the basic skills in terms of HTML, CSS, and JavaScript to support your data visualization process. So with that in mind, let's get into it. We're going to be creating a stock visualization dashboard using some of the Apple stock data that we saw in my previous tutorial. Step 1 is not required, but highly recommended, and that is to use Git and GitHub to manage your code history. GitHub Desktop makes that a lot easier to do, and we're going to run through the setup of a Git repository using GitHub Desktop. I'm going to open up a new repository and add in the path to a folder that I've set up to store our project code. I'm going to give that a name, Plotly Demo, and a description. I'm going to click to initialize this repo with a README file and create that repository. This is now set up to track our code as we make changes to the code and then sequentially commit and push those changes to our repository. We can see all of those and ensure that we're not going to lose any code if anything goes wrong on our machines. That's just one of the benefits of Git, but I'll let you look into it further on your own if you're interested in some of the other benefits. Now that we have our repo, I'm going to open our Plotly folder in a code editor, and my code editor of choice is VS Code. Code editors provide features like auto-completion, debugging, and then even integration with things like GitHub directly, all in a local environment, which is not relying on someone else's servers to be able to run and test your code. At the moment, we just have an empty folder with our README file, and I'm going to be adding a few of the files that we need, starting with an index.html file, as well as a scripts.js file, and then lastly, a style sheet, which is our CSS file. In terms of populating our file with code, there's a couple of online tools that can help you get started so that you don't have to do everything from scratch. One of these tools is an HTML boilerplate generator, which will help us create the typical code that we need in our index.html file in order for our website to run and be visible in the browser. One tool that I've been using for a while to do this is called htmlshell.com, and it gives you a number of options that you can select based on how you want to build that boilerplate for your HTML file. So I'm going to include a couple of options here, like the viewport meta tag to allow our site to scale up and down depending on the width of the user's device. I'm going to include some of the common meta tags, which are inside the head tags of our HTML file. And then I'm going to include a linked CSS style sheet, and we can just skip the rest of this code for now. So copying in this, we can paste it into our code base. And this just saves us some of the menial work of setting up these tags. I'm going to fill out the information which is going to be relevant to my project, but in your case, you'll want to make sure to include your own data in the values of some of these attributes. Now it's time to set up the HTML elements that we're going to use both for our web page and for the visualization. To do this, I'm going to establish a grid using CSS Grid. And this is where another online tool comes in handy called the CSS Grid Generator. You can go to grid.layoutit.com. You might remember this from Deco 1016. It's a tool that allows us to graphically create CSS grids. I'm going to create the top level layout of our page, which will include a header, navigation bar on the side, and a side on the other side, and then our main content area. This main content area can just be one column, so we'll remove one of the columns here, and then we'll set up some of the values. So for our first row, we'll change that to 100 pixels. And then we'll leave the main section as one fractional width. That's what FR stands for. But we'll reduce the width of our nav and aside elements. Another thing I'm going to do using the CSS Grid tool is create a subgrid inside our main grid element. And this is going to be the grid that I use for all of the div elements that we're going to use to create our plots in Plotly. So for this, I'm going to make it 2 columns and 2 rows, with the top 2 columns in the first row being our first data viz, so I'll call that viz1, and then a viz component for each of the bottom columns. You can see on the right hand side that we get the CSS and HTML provided for us based on the grid that we've created in the GUI here. This is one of those tools that really just helps speed up your development process, but isn't anything that you wouldn't be able to do manually in the code anyway. So I'm going to copy that HTML across to my code, putting that inside the body tags, and then copying the CSS into my CSS style sheet. So there's one last tool I want to show you, which is going to help us a little bit with our CSS, and that is typescale.com. Typescale allows us to create scales for our typography based on numeric ratios. So we can see as I change this scale value, the relationship between our elements, which will eventually correspond to heading 1, 2, 3, 4, 5, 6, and then all of the body elements on our page, will also change. So I'm going to pick a value that I think is appropriate given the scale of the design that I have in mind. And then we're going to grab a font. I'm going to stick with the default here, but you can use any of the Google fonts. And so while this tool is helping us mostly with the mathematics behind calculating our font scales, it's also a really easy way to explore and grab fonts given those certain ratios for both heading levels and also the body of the page if you click on this little arrow on the right hand side. So I'll just stick with the default options for everything else, and I'll copy this code back into my CSS. And that's all good to just paste in. You just have to remember to grab the import link and then move that up to the top of your CSS file. All right, I'm going to jump over into the scripts.js file now, and I'm going to start to include some of the variables that we need to establish our project. First off, I'm going to create a variable for some colors that I know that I want to be using in the project. This is a really good way to think about your styling for your plots. Because the styling gets handled in JavaScript rather than in CSS, you can create variables to store your styles just like you would create variables to store your data. So in this example, I'm going to create an object for a few different colors that I'm going to be using for our lines. So the reason that I've used a const declaration here is because this object won't be changing at all during the execution of our JavaScript. That's always going to remain constant, which is what that stands for. The next variable I'm going to set up is a constant for our configuration in Plotly. Even though we're going to be making a number of visualizations and different plots, this config is going to be the same for all of them. So I'm going to be setting this up as a constant as well. The display mode bar property will either show or hide the default tools that you can use within Plotly on your graphs, such as zooming, panning, opening in Plotly dashboards. We don't want to provide the user that level of control for this particular visualization, so I'm going to set that to false. And then I've set responsive to true, which is going to make sure that each of our individual plots will be scaling up and down. And seeing as we've set up some of those numerical values inside our CSS grid, the plots will now scale according to our grid as well. Next thing I'm going to create are the DOM element references that we need in order to initialize our plots. And because we're going to have 3 separate plots on this page, I'm going to require 3 different variables to keep track of them. So these IDs will need to also be set up inside your index.html file, because at the moment from our grid generator, they've just been created as class names. Just while I'm still in the HTML file, I'm going to add our script link to the bottom of the body. That's just pointing to our scripts.js file, which is at the same folder level as all of our other index.html and stylesheet.css files. The reason that we want to include this script file at the bottom is because we are trying to capture some of those DOM elements. So we want them to exist before we try to store references to them, unlike the script file that we need to put at the top, which is a link to the Plotly CDN in order to actually initialize all of our plots. So that should be it for the index.html file. We can jump back into the scripts.js file now and start to import our data, which we will then use to create our plots. Just like in the last tutorial, we're going to be using the CSV import functionality of the D3 component of the Plotly library, and we'll be feeding that in a link to a CSV file and then running a callback function, which is where we're going to initialize our plots. The function that I'm calling here is going to return the input parameter of rows, and that's going to give us each individual row out of our CSV file. So the first plot that I'm going to set up is a simple line graph, and that's going to be showing us 2 values. We want to see the highest price of the stock per day, and we want to see the lowest price per day as well. So we'll need 2 trace objects to do that. I'm going to create the objects to store those trace data, and then I'll explain some of the individual properties at the end. All right, so we've got the type and the mode, which are 2 properties for Plotly to know what type of plot we want to create. The type is scatter, and then the mode is lines, which will connect all of our individual points within that scatter plot. The name will then be used as the legend key for that particular trace or that series in our plot. So it's really important to have a name property inside your trace object. Then we've got the 2 values. This is our data for the X and Y axes. We're going to be using 2 columns from our CSV, and we're going to need to do a little function here to extract the individual value for each of those columns depending on the row. So we'll write that in a second. But last thing in our trace is the line property. This is where we do all of the styling for our individual lines. And the main thing that I'm going to be changing here is the color of our line, where the property is using the value that I set up in our original constant for line colors. So here I want to use our green value. This way, by using that object, I can see at least a human readable name of that color. And then if I want to change and theme that particular color across my entire site, I only ever would need to update that value once in its top level constant variable. I'm just going to copy and paste this trace for our second trace, which is going to be the lowest price of that stock. And then I'm just going to update our two properties to meet the needs of the CSV headings that have been set up. So that's the AAPL.low, that's coming from the CSV, whereas the AAPL.low value in the name is created by us. I'm also going to update the color to be red. So we'll have a green and a red contrasting line on our plot. So let's write the function that I mentioned that we need to unpack our CSV data and provide us each of the values for those rows. This is a relatively simple function that's just going to remap a value from one array to another, returning us the individual value for each row. We're going to put in two input parameters here. Firstly, the row that we are currently looking at. So this is going to come from our rows variable or input parameter from the callback function. So we'll call that the same thing. And then what is known as the key. All right, so what this line does is return a value from our map function on all of the rows that we're getting from our CSV. And then for each of those rows, we're going to be running a single function. And so that's why we have the single variation of the word row there as the input parameter. And for each of those rows, we're going to be returning its key value, which means that that's the value of whatever is in the array for that row, given a name. So the key in our case here is apple.low. The key for the first trace is apple.high. Now back inside our CSV function for our callback, we're going to add in a new variable for the data. So the variable data, we know that we're going to have some more data, so I'm going to call this data1. Also, I'm just saying I need to update the trace one in that second trace. And then the value of this data variable is going to be an array with both of our traces inside. You might remember from the last tutorial that when we want to set up a new plot, there's a few input parameters that we can put in there. The first one is the actual div that we're going to be using, which we've stored as a variable up here. The second one is the data itself, which we now have. And then the third input parameter, which is optional for Plotly, is the layout. We want to control a bit more of the layout here. So we're definitely going to be creating our own layout input. And the easiest way to do that is as another variable, which we then will build out our object structure with all of the different properties to create that layout. And then we'll pass in that whole variable when we make the plot. So I'll create a variable called layout1, which is going to correspond to our data1 and our plot1 div element. And then the value of that is going to be determined by what kind of plot we want to create. So we know we're creating a line chart here, but there's a few other things that we can include in the layout to make it easier to navigate and explore our data. We'll start off with a title. Title is always really important to make sure that you're describing what your chart is displaying to the user. Now, this next part is where it's going to start to get interesting. Because we are working with a certain type of data, which is the stock price of Apple over a given period of time, we can go beyond just the default layout options for an X and Y dimensional chart. In Plotly, this is known as a time series chart. So we're going to be creating the axes to not only just display the data that it's interpreting from our data objects, but we're actually going to specifically tell Plotly that the X-axis will be measuring time And one of the affordances that provides us, one of the functionalities that we can then code into our layout object, is being able to control the units at which the user is seeing that graph. In order to do that, we want to create a few more properties, and these are relevant to their specific axes. So that's going to be the top level property that we create. So x-axis. And the thing that we want to control within the x-axis is known as the range of dates that we can see in the total scale of our data. So firstly, I'm going to set the property auto range, and I'm going to set that to a value of true. That's going to automatically scale our plot or our chart to meet the minimum and maximum values for our dates. Then the next thing I'm going to set up is called a range selector. So this is going to give us predefined intervals to look at our graph from different perspectives. We do this using the range selector property, which is an object that contains an array of buttons. Each of the objects in this array, there's a few sub-properties such as the count, the label, the step, and the step mode. So the count is the actual data unit, the label is what the user will see, the step is the amount or the division that is used for that unit, and then the step mode determines which direction that amount will go from a given date. So in this case, we'll go backwards 1 month. So I've created another object in our array for 6 months, which is a 6-month period. And then lastly, you can see the step all property, which doesn't require any other properties, will then auto scale and show us all of our data again. The last thing I need to put in is the type for this x-axis, which is date for us. So I want to test if this is working. The last thing I need to do is add our plot, and I do that using the plotly.newPlot function, feeding in those input parameters that I mentioned before. So the first thing is our reference to the div. This could be a string with that div name, or it can be a variable pointing to the HTML element, which we established before. Secondly, we want our data, which is the variable data1. And then we want our layout object, which is layout1. And finally, our global config that we'll be using for all of our plots. That should be everything we need in order to see this plot and be able to use the range selection tools. So I'm going to run this using the live connection server that Alex mentioned in his previous tutorial video. So if you haven't, jump in and install that extension in VS Code. Then when you click on go live, it's going to start up a web server at the port 5500, and you can then open up that server. So this is the first plot that we've just created in JavaScript. You can see that as I move my mouse over the plot, we're getting the default functionality of highlighting our current location on the x-axis, which is the date, and then also we're getting both the values for our traces at that given point on the x-axis. What I was mentioning before with our range selectors are these buttons up in the top left corner. When I click on the 6-month button, you can see that the time scale on the x-axis updates to show us only 6 months of our data. Same with the 1 month, down to a smaller time scale, and then we can return to our maximum time scale using the all button. We still have the zoom functionality that's provided in Plotly, where you can zoom in by selecting an area and then double clicking to zoom back out. But these small buttons just give us predefined steps and intervals for us to view our data. And especially for a use case like finance and checking the stock prices, this is a really common design pattern that you'll see in data visualizations. So what if we wanted to be able to see a limited subset of the data, but then be able to scroll through the different time periods in order to see how that data evolves? For that, we have what's called the range slider. So this is another property that goes into our layout. We can add this just directly after our type that we've created for the x-axis. We're going to add in the property called range slider. Range slider is an object which takes in another property for the range that slider will allow you to see initially. And the value for range is an array with the minimum and maximum date. I happen to know these dates just off the top of my head, but if you needed to find them, you could also calculate them programmatically in JavaScript when you're doing your data imports. This raises a really important point about time series in Plotly. You can see that the format of the date is year, 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 hyphen, then the month, month, hyphen, and then the day, day part of that date. In order for the dates to be recognized by Plotly and used on the x-axis as the type of date, especially with the extra added tools such as the range selector and range slider, your dates have to be in this format inside your data. This data format is known as the ISO 8601 standard for dates, so you can Google that if you want to see a little bit more information, but it just is a reverse order which makes our dates really easy to sort and interpret by machines. Now, seeing as we have the live server open, I don't even need to refresh the page, but we can see the change immediately on our server here. So now this bottom section is showing us the entire range of our dates, but as we manipulate these controls at the end, we can see that the overall scale of our data in the top plot is changing as well. So this bottom section is the range slider that I was mentioning, where we can change the start and end dates that we're looking, which is changing the period of our time. And then we can also use the whole slider in order to scroll through our data. This is kind of similar to the mini map that we can see in VS Code, which has all of our code that we're able to slide through, except with the added controls of picking the start and end points. So how does this actually help us? Well, one thing is that it gives us much more granular control of the data that we're looking for within the overall scale that's been established for our plot. So as I move this up and down, we can see that the trends will become more apparent from the past, or you might just block out a certain point of interest, such as this big dip around September 2015. This will allow you to then dig into the data at that certain period of time and try to understand what the story was, which you will then be able to communicate with your audience that is consuming your visualization. While we're on the topic of tools that will help your user understand the data, I want to mention spike lines in your plots. At the moment, we can see the values of our series or our traces when we hover over a certain point in the plot, but a spike line will help connect these two values, making it just a little bit easier for the user to interpret their relationship. Jumping back into our code editor, the spike lines are added inside our layout object as well, and they are also relevant and relative to the specific axes. So underneath our range slider that we just created, I'm going to add a few more properties in order to create these spike lines. So there's a few properties there. Show spikes with a value of true will enable the spike lines. Setting the spike mode will determine whether the spike just goes to the axis to show you at which point, or actually goes across the whole width of the axis to show you multiple relationships with other series, which is what we want in this case. Then we're setting the spike color, again using our constant, which stores some of our color data, and we can also change the thickness of those spike lines as well. So let's take a look at what that looks like in the code. Make sure that you save your JavaScript file and then jump back over to your browser. So you can see now as I hover over the series themselves, the blue spike line is appearing, and that's going all the way from the top of our plot to the bottom and cutting through both of the traces on our plot. If I zoom in a little bit further, it might make it a bit easier to see this, especially if I'm at a period in time that has quite a lot of difference between the values. So there we can see the spike line appearing, which will then show us at exactly which point in that horizontal axis are these two data points being represented. This becomes more useful the more lines and traces you have on your plots. So I want you to have a think about how you might be able to use spike lines in order to better communicate information to your target user. All right, so this plot is showing us the high and the low prices over time of Apple stock. But there's a bit more information that I want to see in order to try to interpret this data. One of those things is the trade volume, how many shares were being traded on a given day. And then another one is a candle chart of this same data, which is just more of a typical financial visualization, which represents a few more variables around the opening and closing price of a given stock, which allows you to visualize the relationship of those prices over time. In order to do this, I'm going to need to create some new trace objects in my code, as well as some more data variables and layout objects for these new plots. In order to try to organize my code, I'm going to keep all of the traces grouped together, all of the data variables grouped together, all of the layout objects grouped together, and then all of the Plotly new plot function calls grouped together as well. This is totally up to you, and if you would like to instead create each plot and group them together, that would be fine as well, but just stick to whatever convention you end up deciding on. For me, I'm going to put our new trace object up here with our other traces. So for this second visualization, I want to visualize the trade volume given a certain day. So this is going to be another line chart, which will use our type scatter, mode lines, and then obviously a different name, as this is now a different piece of data being represented. For the X and Y values, I'll just copy again the calls to our function. We're going to be using the date on the X-axis for all of our plots, but then instead of the low price, we're going to be grabbing the volume, which again is coming out of our spreadsheet with our CSV data. This is the heading for a column in that CSV. Lastly, I'll just change the color as well using our line colors object. Pretty simple to set up the data variable for this. It's just an array with our single trace inside. Then I'm going to create the layout for our plot as well. Starting off with a useful title. And then we're going to again create the X-axis property within our layout for styling some of the axis control. I'll set the type to date here. I'm not going to worry about the spike lines for this chart, but I am just going to set the auto range property to automatically scale based on our data. Then we can jump down here and create the plot for our second plot. This time using the plot2 div, data2 variable, the layout2 object, and then again our global config. We'll save that and open up the browser, and we can see now that the browser has our first plot, and then in the grid container where we set up our second viz element, we're now seeing the volume data as well. So jumping back into our code, I want to create the trace variable for the candlestick plot. That was that last plot we talked about adding into our visualization. So I'm going to add this plot in, call it trace3. And this will be slightly different from the others, as this is not a typical line plot. This is going to require a few more variables here, and you can check out what those variables are in the Plotly documentation for a candlestick chart. So I won't go into too much detail about what we need here, but you will see a few familiar properties and then some new properties with different values as well. Okay, so that's everything we need for our data. Now I'm just going to create the data variable itself. And then lastly, I want to create the layout object for this plot. So I want to turn the legend off for this visualization, and I also want to turn off the range slider as well. By default, the candlestick chart type has a range slider, but I eventually want to control that in another way. So I'm going to turn that off for this particular layout. I'm going to copy this line again and then just change some of these variable input parameters, so data and layout. And then we'll save that to see our new plot. All right, so that plot has appeared there. We can see now, we can still zoom into certain periods and see how the different trading outcomes appear over time on this plot. So now we have three different visualizations of the exact same data source, which is coming out of the CSV. And we have the ability to scale in all of them, view different parts of it, and then try to interpret the data and tell some kind of story. One issue that we have is that at the moment, all of our scales, although they happen at the same period, they're disconnected at the moment between our plots. I'm going to show you a bit of a workaround in order to connect up the time scales of our plots when we're using the same data source. This is a really powerful way to be able to explore multiple perspectives of the same data set using a single overview in your visualization. So to do this, we're going to create a new function inside our CSV. It's important that this happens inside the CSV because it needs to happen after you've created the plot. So once the plot has been created, we're going to be working off our plot1 div element. That's the first major plot. And because that's the biggest plot that we have on the page, that's the one that we want the user to interact with the most and then control the other two plots as a result. So I'm going to create a event handler, which is listening out for when this plot1 div gets changed because of the layout. So I can do this by using that name of the variable, plot1 div, and I'm listening out for the event plotly underscore relayout. When that event gets called, I want to run a function. This is another callback function, which is going to provide us an input parameter of any of the data that gets communicated when that event happens. So I've created our function, which has the event data input parameter, and inside the brackets for that function is where we're going to be doing all of our work to update the second and third plots based on the user input and interaction with the first plot. First off, to just see what's happening, I'm going to log out the console data to our JavaScript console. Now, if I jump over into the browser again, and right click and go to inspect, or go into the developer tools any other way you know how, jump into the console, we can see that originally that log has fired to tell us that auto size should be true. If we then create a selection in time, we can see that the console log is telling us that something was changed, and it's given us two values here, the x-axis for the range at the beginning, so the minimum date, and then at the end, which is the maximum date. If I then use the range slider to change the date, we're going to see a different result getting logged out to the console, which is a range still, but it's an array still together as opposed to the array which has been pre-split when we do the selection in the main plot. When I then double click on the graph to return back to our original scale, we can see that the log tells us that a property has been updated, which is x-axis.autoRange, and that has been set to true. So the problem that we're encountering here is that depending on the type of interaction that we do, whether that's click and select, or to scale up the range slider here, or move that date versus double clicking to reset everything, we're getting different outputs in our console. That's okay. It just means that we need to account for those outputs and create the structure in our code in order to handle them. So that's what we're going to do now. Under our console log, we're going to create a variable, call that update. That's going to house any information that we want to pass back to Plotly based on the logical conditions that we're working out from our event data. So probably the easiest one to look for first is the auto range property that was getting set to true if that was reset based on the user double clicking or pressing the all button. So I'm going to make a simple if statement to capture whether the event data is telling us that that property has been changed. I'm going to use the key of that object. So the key in this case is the name of the property that we saw in the console log, which was x-axis.autoRange. So this if statement is saying that if the event data x-axis.autoRange property was true, it's the same as saying equals true, but we don't have to write that part. If that is true, then do this next bit of code. What we want to do here is add to our update variable. So we're going to set the value for that update variable with a few properties that we want to communicate back to Plotly in order to update both of our subplots. The data that I'm passing into this update variable is the same data that would be inside the layout object for that plot. So we can control the layout of our second and third plots using this update object. So for our first case, when we are resetting the range, we want to set the x-axis property for the subproperties of auto range to equal true. We also need to include something called fixed range. I'll explain that when we see the plot. And then we're also going to just ensure that the range slider doesn't become visible, which it might by default otherwise. Now, to get that to run on our browser and update when we change something on the initial first plot, there's one last thing that we need to do, and this is going to happen outside of our if statement, but still within the event handler. So we'll just come to our last bracket of the if statement, give ourselves some space, and then we're going to insert the line plotly.relayout. That's calling the function to relay out a certain div given some additional update information. We'll copy that again for the third plot div, but the update will remain the same because that's being set based on the event data. So save your file, jump over into the browser again, and we'll see that when I initially select the value, it's not updating our second and third plots because they haven't listened out for that type of update yet. But when we have scaled in either of those plots as well, and we double click on our first plot to reset the scale, we'll see that our second and third plots have also been reset based on that interaction. All right, so now we need to account for those other two conditions. Firstly, we'll create a condition for the selection in our timescale, and then we'll create a condition for the drag movement in the range slider. So I've just created two temporary variables there to extract from our array that we were getting for the x-axis.range property, the first and then the second index. Then I'll recreate the update event. I'm just going to copy it from the last condition, and then I'm going to add one extra property in here. The extra property that I'm going to add is the range property, and the value for that is going to be set as an array based on my two temporary variables. Before I show you what that looks like, I'm just going to finish the last condition, which will be the else part of our if statement. I'm going to need these temporary variables again, except this time, instead of them coming directly from the array, which is x-axis.range, they were pre-split in the array. So I need to go x-axis range 0, work that out due to the console log, and then same thing with the second parameter, brackets 1. Then we'll need our update again, and this update is just going to be a direct copy from the last one. As long as we've changed the X scale start and end values, this will all work out on our page. One thing I need to change here is the auto range property to be false for the second and third conditions here. This is going to make sure that our range is set explicitly by the X scale start and end values, which is also why we need the fixed range property to equal true. So we're manually setting this using the fixed range that we provide. When we open that up in the browser and refresh the page, we can see that we start off with all of our graphs auto-scaled. Then as soon as we select a time period in our first plot, we'll see the timescales update for all of the graphs on the page. So all of our plots are now being relayed out based on the interaction that we're capturing on this first plot. If I drag the slider, we can see directly how that affects the additional plots that we have on the page. And then of course, if I was to double click and reset, so do our additional plots. This also works with the range selectors now. So due to the fact that we're using a consistent type of data, which is the date field, and then the actual range selector and slider functionality through Plotly, we're able to link all of these plots together and therefore explore the data to a greater degree. So what does this actually help us achieve? Well, for one, we can see some anomalies in the data that we might want to explore a little bit more. For instance, we can see around the 24th, 25th of August, there was a huge drop in the price at the lowest point for the stock. If I zoom into that particular drop, we can see that at the lowest, it was $92 per share. And that actually corresponds with an increase in volume of sales. So this makes sense. As people are selling off their shares, the price is going to go down. People are selling without those shares necessarily being bought, which will then result in a lower price. This is also reflected in the candlestick chart, which we can see has dropped down on the 24th with a low of 92, although it did rebound on that day, closed at $103 before seeing a bit of an increase over time. As we then expand our time horizon, we can see that that dip, although quite drastic on the day, didn't last for too long as the stock went back up to its previous price point. So as data explorers, data scientists, data storytellers, we can then test out some hypothesis. What made the stock go down on that day? If you went and researched that on that particular day, there was about an 8% drop in the price of the stock due to several conditions, one of them being what is termed as Black Monday in the Chinese market, and a huge resulting sell-off of a lot of stocks across all industries. Another point in the data that we might want to explore, if we reset our time horizon, is the other lowest point in this particular graph. So this is roughly the same price, $90, which is the same low that we saw on August the 24th. We reached that low again at around May the 13th in 2016. So looking into this again, we can see a huge drop off around the beginning of April, which then carries over into May, and the price will then slowly build its way up. On May 16th, a date that I was able to search directly for based on the current conditions of the stock at that time, I found out that Warren Buffett, one of the biggest investors in the world and one of the richest people in the world, was able to buy about 10 million shares in Apple at that exact moment. And so this is a really classic investment strategy, to buy in the dip, to buy when the price is low. And then we can see in the volume that on May 16th, there was a fairly sharp increase between a previous volume of around 44 to 61 million shares sold on that day. And so knowing that Warren Buffett bought about 10 of those shares on that day, we can work out that Warren Buffett bought roughly 15% of all the Apple shares bought on that day. That's crazy to think about, and there's surely a lot of reasons as to why that strategy was put into play on that particular day. But these are the kind of stories that you can start to unpack based on our perspective into the different facets of this data set. So that was a really technical walkthrough of starting from scratch with Plotly to develop an interactive visualization that helps us explore a specific data set. I hope that the code didn't scare you off, and that by seeing it step by step, you can understand that it is just a process that you need to follow and that it's not overwhelming. You just need to think about it piece by piece by understanding what are the requirements from Plotly in terms of having all the variables, the different data objects, and the config and layout options set up for your plots. Then we saw a little kind of hack workaround of how we can connect our plots. There are much more sophisticated ways of doing this, such as cross-filtering and creating linked data sets, but that's a little bit too much to go into for now. So hopefully that little demo showed you as well that we can actually link up our visualizations using the same data set to explore them from different points of view. In your tutorial today, you should walk through your own assessment projects with your tutors, trying to improve on them using some of the techniques that you might have learned from today's video. And I really hope that I get to see them all at the end to see your awesome visualizations. I'll see you guys next week where we start to look at interactivity in a little bit more detail, looking at hover events, click events, and then things like transitions and animations using the Plotly library. Cheers, guys.